Okay, I recorded this once and the sound turned out to be very bad. I'm not getting a good sense out of this bloody two Bluetooth earphone I got, but nonetheless, let me try again. So, we've been talking about a bunch of evolutionary traits that maybe have led us to create these climate change conditions and exploitation of resources beyond sustainable limits and so on. This is a nice paper that talks about leveraging neuroscience for climate change research and, in fact, for climate action. We talked about cooperation, pro-social behavior, and so on. What is this about? Anthropogenic climate change poses a substantial threat to societal living conditions. Here we argue that neuroscience can substantially contribute to fight against climate change and provide a framework and a roadmap to organize and prioritize neuroscience research in this domain. We outline how neuroscience can be used to investigate the negative impact of climate change on the human brain and identify ways to adapt as well as understand the neural substrates of decisions with pro-environmental and harmful outcomes and create neuroscience-based insights into communication and intervention strategies that aim to promote climate action. The paper is also a call to action for neuroscientists to join the broader scientific efforts to tackle the existential environmental threats Earth is currently facing. Well, existential for who? Maybe for us, but let's leave those descriptors aside. Just briefly, we argue that findings from different neuroscientific domains, such as environmental health, decision, social, or affective neuroscience, can advance our understanding of the reciprocal relationships between the environment and the brain. So we looked at one study which looked at the uh, interactions or feedbacks between inequality and biosphere. So here we are looking at the brain and the environment. Give me a second, maybe somebody is knocking on my door. No, the sound is coming from outside. Okay, so sorry about that. This is the jeopardy of working from home. We present a succinct overview of how neuroscientific research can provide insights on what a changing climate means for human health and well-being and how to identify promising strategies to help adapt to and mitigate climate change. So this is building on previous neuroscientific contributions and so on. What is the neuroscience history of environmental impacts from the human beings and back from the environment to the human beings? Stretching back to research from the late 1940s, neuroscientists have investigated how the physical environment affects the brain and behavior. Observational studies showed that rodents raised in enriched environments learn faster than rodents raised in sterile laboratory settings. So that relates to how poverty affects people, education, brain growth, brain development, sorry, and so on. Today, environmental science investigates the reciprocal relationship between organisms, particularly humans, and their environment with a focus on neural and psychological processes. Right? So this makes sense intuitively that we are strongly interacting with the environment in a positive and negative way, and the environment can have a positive or negative impact on us. Neuroscientific approaches thus provide a unique perspective on the interactions between organisms and their environments by identifying the neural substrates and mechanisms underlying these interactions. They can identify biologically plausible candidates for the cause-effect relationships between changing environmental features and changes at the behavioral level. For example, growing up in a household of low socioeconomic status has long been associated with poor health outcomes and impaired cognitive and emotional development. Neuroscience has identified neural processes by which factors related to low socioeconomic status result in specific neural disturbances in cognitive and affective systems, including lack of cognitive stimulation, exposure to toxins, poor nutrition, and heightened childhood stress. Okay, so neuroscientific methodologies have contributed to a better understanding of the neural and cognitive implications of poverty, allowed for identification of negative consequences that can potentially be reversed, and enabled the development and evaluation of powerful targeted interventions. So obviously there are lots of understandings and tools that can be, brought to bear upon this idea of humans and interacting with the environment and degrading the environment. We said in the evolutionary podcast so far that we have become good at constructing niches opposed to just adjusting or evolving to fit into the niches given by nature, and then we adapt to the constructed niche and we get better and better at exploiting resources, and we keep growing in scale. So here are the reciprocal relationships between the brain and a changing environment, and there are two pathways. In pathway A, the impact is from the environment to the brain. So we have things like extreme weather and heat events, poor air quality, stress and anxiety affecting the brain. And there are ways in which protection from extreme weather can be accomplished. Exposure to nature helps in well-being and hence health. And you can have many virtual strategies where you induce uh, the brain to even, the sense of cooperation, the, sorry, uh, there is a perception of cooperation or fairness that induces pro-social behavior, especially among the poor, for example. Okay, so brain can be, you know, trained to say things are not bad, that you are overestimating unfairness, inequality, and so on. Not to cheat, but to get them to be more positive in their thinking. So, how do you go from the brain to the environment? So, here we are, pro environmental behavior, consumer decisions, and investment decisions in terms of not investing in fossil fuels or expensive things that you don't need, investing in efficient appliances, cars, saving energy, etc. And that affects the brain to then improve climate change communication, behavioral change strategies, and overcoming psychological barriers to maybe be part of the groups in climate change action, or so being part of the community in terms of reducing our impacts and so on and so forth. So in Pathway AIM, the questions to be answered are: how does climate change affect the brain? And can neuroscience help with climate change adaptation? In Path B, the idea is to try and answer questions: what drives environmental behavior at the neural level? And how can neuroscience inform climate relevant behavior change and communication strategies? Okay, so sounds very nice. The proactive role of psychology in addressing climate change has been looked at, emerging at the same time as environmental neuroscience. Environmental psychology initially focused on exploring how aspects of the built and natural environment affect human behavior, productivity, and well-being. Exposing yourself to nature and greenery, bird sounds, etc., improves your well-being, which means productivity, behavior, relations, etc. In the 1970s, research turned towards understanding the psychological factors underlying human influences on the biophysical environment, such as air and noise pollution, and the negative effects of these changes on human health and well-being. Today, many more environmental psychologists focus on finding ways to change people's behavior focus to reverse environmental problems, while at the same time preserving human well-being and quality of life, an approach often referred to as sustainability psychology. By combining and integrating a focus on the impact of environment on the human mind and a focus on the impact of human behavior on the environment, the field has uncovered promising bi-directional and reinforcing relationships between exposure to different environments and the promotion of pro-environmental cognitions and behaviors. Okay, so there are ways to understand psychological factors underlying sustainable decisions, behaviors, and practices that are aligned with emissions reductions while making these changes compatible with human well-being. So we've been saying maybe evolutionary traits are in somewhat uh, a barrier to global collective action. So this is not talking about global collective action. So this is slightly different, more optimistic in terms of our ability and brain's ability to change our behavior, reduce our impacts on the environment. But this could still be intra-group cooperation, cultural mores within the group and not across the groups. So we are still not really saying all the evolution and evolutionary traits we talked about are overcome by neuroscience. Okay, so key questions we already answered for pathway A and B, uh, or at least we asked already. And there are this is a non-exhaustive selection of cognitive and affective processes and the related brain regions that play a role in the context of climate change. I won't read all of it, but it's very interesting to see that we actually have pathway A and B again with relevance for climate change, cognitive and affective processes involved, and possible neural substrates. So it directly goes to the brain and its functioning. Climate anxiety and climate-related post-traumatic syndrome are in path A. So that's going from the environment to the brain. So it includes things like fear and anxiety and fear conditioning and extinction. You can go and read what that means. You have to be careful there. So there is a reference for that. So the possible neural substrates include amygdala, periaqueductal gray, ventromedial prefrontal cortex, amygdala, and insula. So amygdala is this little almond-shaped two parts, a left and right, and there are many details of how our physical experiences are translated to emotional responses to similar physical stimuli in the future. So you are, post-traumatic syndrome, for example, post-traumatic stress syndrome, for example, post-traumatic stress disorder, PTSD, for example, is manifest in the amygdala as well. Okay. Path B, brain to environment, is awareness of future consequences of climate change, which includes mental simulations of future events. So you imagine, may get anxious about it. This includes ventromedial prefrontal cortex, hippocampus, parahippocampal cortex, and so on. And there is also translation of intentions into concrete actions, which is about cognitive control, and then that includes dorsolateral prefrontal cortex and anterior cingulate cortex and parietal lobe. As you can see, I'm not a brain scientist, so I have trouble reading those. So nice details here in terms of actually what the brain parts involved are and what the cognitive and affective processes are and how they map to the environment from, you know, impacts from the environment to the brain and vice versa. So this paper is nice in the sense they also argue about how they have to also worry about the costs and benefits of climate neuroscience. We do a lot of modeling, projections, predictions. These models are very heavy or computationally, which means energy wise. So there is always a question of whether we need to project out to 2100, whether that information is useful or usable, and who will use it, and so on. Similarly, here, while the article highlights the potential contribution of neuroscience to understanding and addressing climate change, it is important to consider that neuroscientific methodologies can extract considerable environmental cost. So, researchers and editors need to measure when disseminating neuroscientific results, be sure of the cost benefit analysis as well as be aware and transparent about the claims that they realistically can or cannot make. Okay, so, overstating the impact of science is very common, and overstating the usefulness of projections to 2100 is also common. That's a big elephant that's moving and it's hard to steer it right now. Okay, what are the conclusions? I'm being very brief. It's a very nice paper. Please go back and read if this topic is of interest. I think it is a very interesting topic. When I read it, I always condense it into main points according to me, but you need to go back and read if you want more details. Anthropogenic climate change poses a substantial threat to societal living conditions. Here we argue that neuroscience can substantially contribute to the fight against climate change and provide a framework and a roadmap to organize and prioritize neuroscience research In this domain, we outline different key questions and pathways to which neuroscientists can contribute, as we saw before. In pathway A, we propose that neuroscience can evaluate and quantify how the different consequences of climate change impact the brain, and we discuss possibilities for how neuroscience might be leveraged to better adapt to these negative consequences. In Path B, we discuss existing and potential future research on the neural substrates of decisions with pro-environmental and environmentally harmful outcomes, and explore how neuroscientific knowledge can inform communications uh, and intervention strategies to promote climate action. We emphasize the need for purposeful and impactful research, international collaboration, and interdisciplinary integration to make notable progress in addressing climate change, bridging levels of analysis from neurons to societal actions is crucial in solving these existential challenges. Okay? Anything you can do to bring about pro social, pro environmental behavior, climate action is, of course, useful. So, especially since we have evolved in a certain way and our brain works in a certain way, if we can use the understanding of how the brain works first to, let's say, do environmental harm and then to try to correct it, if there are ways in which to prevent the harmful actions in the first place and then also induce behaviors to reverse the harm that is already caused, then it's really a great direction for research, right? So let's leave it here.